guess what? I just got back from China, like I've said a million times. I'm still excited about it. But one of the main things that I picked up in the electronics markets in Shenzhen was this, just a whole bunch of surface mount soldering tools. And I'm really excited to have my own setup for this, so I thought that I'd give it a whirl with the new Boldport Club project. If you're not familiar, you get a PCB in the mail every month. They've actually just sent out the next one as well, so I'd better get snappy with this one. And it's perfect. It's all surface mount. So I'm excited to try this one out. You can check out the link in the description of this video if you're interested in learning more about this particular board or about Boldport Club. Alright, so I also have done a video recently on all the materials that I got, so if you find yourself lost on what any of these things are, just check out our past videos and you'll see one about surface mount soldering tools from Shenzhen, and that's exactly what I'm using here. So, yeah, one thing is this like set of fine tweezers and stuff. One complicated thing about this board in particular is that it is double-sided. So let me take this out of here. Yeah, so we've got stuff on this side. Yeah, we've got stuff on this side. And so that makes it a little bit more complex. Especially, I have to decide how to do this in a way that will permit me to take care of the ICs, the chips on here. You'll see that there are two. And I really don't want to damage those with heat or anything. And I don't have a heat gun. Instead, I have a skillet, which means that, so obviously you buy a skillet, you use it for surface mount soldering. You don't ever use it for food again, ever. Same with toaster ovens or any other heating method. You use it for electronics, don't use it for food. But that makes it a little complicated because that means that I would have to place one side of components down on the skillet at the same time that there already are, like while I'm putting the other ones on the second side. One way you can fix that is to just use a heat gun instead, then nothing on the already done side would be coming into contact with further heat. But what I think I'm going to do is demonstrate one side with surface mount soldering using solder paste, and the other side using a soldering iron. So, you know, that should, if I try to do drag soldering on the other side, if you're familiar with a soldering iron, then that should prevent me from having to deal with any of that. However, there is also a method I found on Hackster.io, I think, when I was Googling around for like ways to resolve this issue, double-sided PCBs with a skillet, and someone said that you could apply the solder paste, apply the components, and then also add a dab of epoxy on each component. And then as you bake it on the skillet, not only will the solder paste melt, but also it'll cure the epoxy, which means that when you flip it upside down, the components will stay in place while you heat up the other side, which is kind of a cool idea. I don't think I'm going to go for that today, just because I want to try the drag soldering. I haven't actually done that before. I have done surface mount soldering in a couple of different ways, with a stencil and solder paste that you squish through with a squeegee, and then you heat it up in a toaster oven, and it's all great. It's like a mini reflow oven, but you never use it for food again. And then I've also done it with just sort of squirting flux all over the board and then applying solder to it with a soldering iron so that the flux sticks to the solder pads. Then you place the components. It's a little tougher because in that case what happens is you end up with a board covered in flux for one thing, which you gotta get off, and that can be a sticky mess. But also you end up with little domes of solder, which if you have very small components, it can be hard to have them stay in place on top of the little domes, because they're flat bottom parts on top of a dome. They want to just like slide off or whatever. And you know, you can either hold them in place with your tweezers while you run the heat gun over them to resolve that, or yeah, you can just sort of trust in the power of surface tension to sort of suck them back into place. You can do both of those things. But okay, yeah, so first what I'm going to do is I'm going to use this syringe full of solder paste. I'm going to take off this orange plastic tip. And I'm going to place onto it. Haha, it's so cool. I haven't done this in ages. So, oh yeah, so we may be in for some thrills and spills, by the way. First, yeah, let's talk about BINCO. A binary up or down counter soldering project. Very exciting. It's got, let's just move this out of the way, huh? It's got a configurable up or down counting mode, which is kind of cool. You can either count up from 0, or I'm assuming down from how many LEDs are on this thing? Lots. Down from lots. I'm not that fast yet. There's a cool way of counting binary that you can do on your fingers, but I haven't mastered it yet. It's like 1, 2, 3, 4, 5, 6, 7, 8, etc. Yeah, I don't know how many you're counting down from, but it's a large number. And then you've got these different buttons you've got, and we have little domes to put on top of those so that when you push down on the metal dome, it connects a couple of contacts underneath. That's BINCO! If you want more info, you can go to the website. I'm going to take these little tips that I got for the syringes, stick one onto the end of here, doot, 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 and you just sort of twist it in, and there it is. Fantastic. So this little vise that I got it calls itself Pros Kit Vise. That's not true at all. It's made of plastic. It's made of partially like nickel-coated plastic. It's not gonna hold up to much. In fact, it's got this little sucker foot, you know, suction cup that you like lever it down and supposedly it sticks onto a smooth surface. It really doesn't. So what I've done is I've taken the liberty of pulling open this rubber bottom here, the base, and sticking a bunch of pennies in there, so that actually holds it down pretty nicely. It's less easy to travel with, but I don't think I'm going to be doing a lot of surface mount soldering on the go, so who really cares? Alright, so I'm going to pop the back cap off of this. Haha, cool. And I'm going to stick in this red plunger here. So that's just going to help us push out the solder. And now I have my little solder application assembly. And what I'm going to do in this case is I'm just going to, I don't have a stencil for this, obviously, so I'm just going to squirt tiny amounts of solder onto these pads. It's going to be a little challenging. And the cool thing about this is that I believe the way that it's done is the LED actually shines through this hole to the other side, which is kind of cool. Also, forgive my ancient nail polish. I've been kind of under the weather this week, and so that's my excuse for being slovenly. We've got all our components out. I also have this adhesive packet that it came with, adhesive sheet, and you're supposed to like cut off bits of that to use to attach the little snap domes onto here. So what do we got? Oh, it's already going everywhere. Let's have a look. We've got poor focus. Let's see. Wrong way. There we go. Okay, cool. So what do we got? We have a big coin cell battery holder. We have a bunch of LEDs. We have 2 little guys, 3 little guys. What are these? Oh my, it's a tiny transistor! It's so cute! You can tell because it's got 3 little legs on here. Oh, you can't see that. Well, I'll get the you know what? I'm going to focus closer and I'm going to bring the stuff to you so you can see it. Okay, here we go. Tiny little transistor, adorable, 3 little legs, great. I can't help it, they're adorable. Okay, let's see what we got here. These both look like resistors to me. One says... oh boy, that's very small. I think that's the 47 kilo ohm. That seems about right. $4702. Cool, yeah, it says 4702, which you read it basically the same way that you read the numbered stripes, the colored stripes on regular resistors, through-hole resistors. 4702 means 4, 7, and 0 are your significant digits, and you add 2 zeros onto the end of that, which gives you 47,000. Cool. What is this one? Got a couple of capacitors in here too, so wait, this one also says 4702. Oh, we do have 2 of those. Okay, cool. You can be friends. I'm really excited about this, guys. I'm gonna guess that our ICs, our little chips, are in here. Wait, no, there's one in here. Cool. And then this is presumably the other one, wrapped in anti-static foam, anti-ESD electroshock discharge. We got some little button domes. I actually have to cut a leg off of one of these. Oh, it's already done. Cool. So you'll see that on, well, I'll show you later. On the PCB itself, there's one of the button connectors shows a missing side and a bar that will be connected to it. And we'll get there. We'll get there. Probably with the soldering iron. Okay, then we have a buttload of resistors, which is great. These guys are, what are they? 1.5 kiloohms. Let's double check. What does it say? Oh, here we go. 1501. So that means 150 and then one more 0, which means 1500, which means 1.5 thousand. 1.5 kiloohms. Cool. This is really hard to focus for you. Sorry. There we go. Cool. And then we also have, I think this is our capacitors. Yeah. So they're all one, it looks like microfarad on the page, but it's kind of hard to read. Okay, cool. CO1 is capacitor 1, and it says DNP, or do not populate. Okay. So I've actually made a couple of marks on here already with a Sharpie. Where is CO1, I wonder? It's not on this side. It's on this side. Okay. It's there. So I'm gonna mark that with my Sharpie real quick so that I remember not to populate that. And then the other 2 little dots here are the 47 kiloohm resistors that are our exceptions to the rule. Cool! So I'm going to start with this side, just because I think drag soldering is going to be more fun and easy on the other side. Alright! That's all our prep work. We've sorted our components. We've set up our little syringe here. We've got our tweezers. I've got my little component bins here with their little flippy open deal, but I am not actually going to be using those today, I think, because I'm going to be using all the components that I have on my table, and it's actually going to be less convenient to have them in these deep wells than it is to have them right on my table. Okay, so to recap, we're skipping the epoxy. We're just going to go straight with this. Cool. Let's try it. I've never actually tried applying solder paste like this before. I can kind of start to see it coming down the little tube. Come on. I'm hoping that it's still pretty fresh. It might have gone a little dry, in which case we may have problems. Okay, come on. This is very difficult. Oh boy. Oh, it's coming out! We've got a little, like, weird doodle of solder paste on the end there. Okay, let's wipe that off somewhere. Here we go. Weird. Ah! I had an option of getting a slightly smaller tip with this thing, but I opted against it. Oh, no. Like I said, it's my first time with this setup, so we may have a few thrills and spills. That's pretty stable. This is going to be very slow, huh? Get on there. Huh, this is pretty messy. The nice thing about solder paste is that it will automatically, like the surface tension will hold it onto the pads once we get everything sort of properly set and we start heating it up. In the meantime though, this is really messy. Oh, there we go. This is starting to work. Just little dollops. Can you see that? Cool. I'm just pressing down with my index finger on the syringe while I do this. I shouldn't need a huge amount, is the thing. So yeah, I've never actually done surface mount with a skillet before, and I'm curious to see how it goes. I have shared links recently to a couple of good tutorials though, so I think it should go pretty well. I'm probably putting too much on here now that I think about it, but we'll see. Ah, it's really tough to get it to come out of here. Uh-oh. Now we just got a huge blob. A nice thing about this method, if I can get it to work, is that I won't end up with sticky flux all over this thing. So that makes it faster to clean up, it makes it look nicer after the fact, etc. Yeah, this is more challenging than I expected. Ah, it really takes a lot of sort of finger strength to make this happen. Okay. So I don't think I apply any solder to the domes, as far as I can tell. I definitely have to provide... Oh, interesting. The transistor is marked as IC10. Oh, you know what? I haven't actually seen any other numbers on here. That's not resistor 101, that's resistor 5. And IC10 is IC2. Interesting. So all the numbering is done in binary. If you didn't catch what I was just going on about. Which is cool. Oh, another cool thing about this board, actually, is that you can see underneath the surface, there's copper in the shapes of ones and zeros, which is really cool. So it has this sort of matte texture with, like, I've never seen a matte solder mask before. That's not true. I really like black solder mask on PCBs, and I see that a bunch. But not a green one. And yeah, so underneath that solder mask is copper, giving it this physical texture of ones and zeros, and that's very cool. I've decided that I want mine to count up, so I'm gonna apply a little bit of solder paste across these two contacts. I will probably still have to heat that up with a soldering iron to get it to bridge the two contacts, because like I said, the surface tension is, when this melts, is going to suck all of the solder onto the little pads. And I've done a little bit of cleaning of them beforehand. Okay, so that should be all of the tinning I need to do. I'm going to have to add the battery holder on after the fact, but I want to keep it pretty flat for now, so I'm not going to add that right now. And then the little reset button over here just gets a dome applied to it with a sticker that will connect this outer ring to the center when you push it down. Yeah, and then these little jumpers are optional. That's a way of applying power to the board if you don't want to use a coin cell. So now comes the fun part. I get to apply all these LEDs. And, so usually, often what will happen with LEDs is that you'll have a dot inside of the LED somewhere that shows you which side is ground and which side is positive. But in this case, I'm not really sure. We have these kind of flask shapes. So I'm gonna check and see if there's any extra info on that. I'm just looking at the BINCO page on Boldport. Follow the infographic for assembly information. Oh, there's a PDF version that you can zoom in on. Ah, beautiful. Oh, that makes my life easier. Okay. Oh, much better. Oh, fantastic. Okay. How the LEDs are oriented, etc., etc. Do they have any information on which way the diodes are oriented? No. Oh, but you know what I can do is maybe I can take another power source and I need a very small power source that I want to put a little bit of power through one of these guys. Maybe with my multimeter. I'll be right back. So here I have a teeny tiny multimeter, which is fantastic. Pardon me. Here I have a teeny tiny multimeter. And I'm going to turn it on and see if I can apply a little bit of voltage maybe. Can I do that? Oh, yes! Cool, there's a diode setting. So I'm going to take one of these guys out. I'm using the tweezers to peel back the plastic on here that holds the LEDs inside the package. Ah! It's always a pain trying to get like one of these things out and not lose it. Okay, here we go. Oh, nearly lost that one. Cool. It's got I wish I could show you this in a little bit better focus. It's got a tiny little plastic dome. My fingers look so huge. That sort of sticks through the hole in the PCB. That's really cool. Oh, it does have a little green dot, but let's use the multimeter anyway and see what it says. So I'm going to place the LED down on the desk. You can see it right here. And now I'm going to try this way. No dice. And what about this way? Also no dice. Great. Well, what about if we test the resistance? Presumably it's going to have more resistance one way than the other, because it will allow current to flow one way and not the other. Okay, so that's completely resistive. What about this? No dice. Oh boy. Okay. Let's double check which side the dot indicates, because I'm pretty sure that that indicates the positive side, but I want to double check to make sure that I don't solder on a bunch of LEDs and then find out that I put them on backwards. In fact, in that case, I could probably just change this jumper so it's counting the other way, like down instead of up. But I want it to count up, and I want to know, so I'm going to look it up. Okay, surface mount, or SMD, LED, orientation, dot. Most often, a small notch or dot will indicate the negative side of an LED. Okay. I'm gonna check with another source just to make sense. Or just to make sure. Usually a green dot on the bottom marks the cathode. Okay, that makes sense. The cathode in the case of an LED, I believe, is the negative side. Yes, okay, cool. I've been doing a lot to try and make sense of the weird flipped way that we explain power with cathodes and anodes and positive and negative, and the way that the electrons actually flow, which is kind of backwards from how we usually think about it. So I recommend going down that rabbit hole if you want to learn a little bit more. The weird thing that was throwing me is that on a battery, the cathode is the positive side and the anode is the negative side. But on an LED, it's the reverse. And that's because of which side is going to be gobbling up electrons and which side is going to be releasing them. And so on both of them, yeah. It's a whole other video that I'm going to get to, and I promise that's going to be really interesting. But yeah, okay, so basically right now, what's the case? We want to count up, which means that we want the negative side, according to this diagram, to be painting that way. So I'm going to do that with the LEDs, and I note that the green dot indicating negative is the same side that has just a small little sort of neck of the bottle shape on this LED. So let's place that. And I'll use it as a guide for all the rest. The nice thing is that I can tell which side is which from the back of this as well as the front, which means that I will have a lot easier time if I have to leave this and come back. I won't have to remember all over again. Okay, so now, ooh, pardon. Now that we have that established, I'm just going to take the plastic off the rest of this rail of LEDs. Or LED tape, whatever. And I'm going to dump them onto my table. And they're going to go everywhere. Such is life. Let's corral these. Doop, doop. And now I'm just going to start placing them. I think it's fun that I'm using a Boldport PCB for this. Because we had a conversation earlier this year. I went to interview him, which is not yet released because there's a lot of transcription. But we talked a lot about failure and allowing oneself to fail. In particular, one cool thing that he said was that if someone like fails at successfully completing a project, but does the work of sharing their issues and their progress with the group, he would just send them a new kit because they adhered to the spirit of the club, which I think is really cool. And so I've chosen this as a very appropriate and timely first project with this whole new SMD rig that I've set up. Oh, a note on SMD versus SMT. So SMD usually stands for surface mount diode, as far as I recall, and SMT stands for surface mount technology. So they're slightly different, but they both mean just like surface mount stuff. Ah! It's obviously much faster to type one of the TLAs, or three-letter acronyms. So you'll see people use those abbreviations. I like how satisfying it is to apply these LEDs. I feel like I made a right choice in doing this side first because the LEDs are kind of self-correcting. Like they have this nice little way of slotting into the board that makes it pretty easy to place them. So as a return to surface mount, it's very good. Oh, speaking of which though, I did also do another surface mount project recently this year. I used stencils at Open Hardware Summit. They had a badge there that was all surface mount soldered, and you would do it at the event, which was pretty cool. So they gave you a little like cut-off rail of or tape of LEDs and resistors and stuff, and it actually worked as a fidget spinner. So you got a skateboard bearing in there as well, which I thought was really nifty. One more thing that I'm kind of hoping about this project is that my skillet will actually get hot enough, oh no, to melt the solder. I've actually just lost an LED. That's going to be fun to find. Oh boy. Everything's going a little bit haywire. Okay, so before we move on, I'm going to really cross my fingers and hope that I can find that other LED. Or maybe I'll come back to that, and then I can set up the skillet and show you all a bit more. Right now I'm going to do the transistor. Which way does it want to go? Pointing away. Okay. Whoop. You just kind of tap these guys into place. The thing with all this stuff is that the solder paste is not an adhesive, but it does kind of help stuff from sliding around. All these resistors, I believe, are the same value. So they're all going to go down, except there's a couple that go on the other side, so I won't take them all out just yet. Yeah, using the tweezers to take the tape off of this stuff is an advance that really helps. I've spent way too long trying to pick it off and get it apart with fingernails that were not sharp enough. There we go. Now that that's started, I'm going to get it very close to my surface, peel off the tape, and let them kind of fall onto there. As you can see, I'm kind of directing them. Okay, and I've left 3 on the tape, so that should be plenty. And these are non-polar, they don't have a side, so I'm just going to grab them and stick them on, whichever way. Ooh! Stay in place there now. And then, again, this doesn't have to be incredibly precise, because everything will kind of get sucked into position. However, at the same time, I am trying to make sure that not too much solder gets between connections, just so that we don't get a lot of shorting. I want to keep that possibility as low as possible. It can sometimes actually help you when there's a little bit of solder stuck to your tweezers, solder paste that is, because it can help you easily pick stuff up. But it can also be really annoying when you're trying to put something down and release it. Oh, I guess there's more on the other side, huh? Sometimes they'll give you an extra LED or two in a package, which will just help in case you drop one like I just did. Sadly not in this case, so I'm just gonna have to live with my mistakes. Okay, oh, here's another one. Nearly forgot about that guy. Okay, so now we've done pretty much everything on this side, and it looks really cool, I think. But I do have to go hunting for that LED, so I'm gonna drop out for just a second, and I'll be right back. And this will probably look really silly. Okay, so since I couldn't find it right now, what I'm going to do is try and use the skillet to melt all the rest of the components onto this side. And then, since it's fairly accessible, once I do find that LED after this video, I'm going to try and solder it on by hand. So that can be maybe the start of our next video. But for now, let's try turning on this skillet for the first time. I'm kind of terrified. I haven't used this skillet before, I just got it at Target. And I also have not used a skillet to solder before. So I'm going to let it heat up for a second and then we'll sort of switch over to there. Yeah. So now that I've sort of used up the solder paste for now, I'm going to take it off. And I'm going to put the cap back on. And that's how you keep it all fresh. There's another suggestion that some people use, which is to put it in the fridge, which keeps the chemical components of it from degassing and, like, you know, basically getting out of solution or emulsion or whatever you would call it. However, other people say that that's a terrible idea because you keep your food in there. So unless you have like an individual mini fridge, some people even use one of those USB can coolers. Unless you have that kind of a setup, they really don't recommend putting it in the fridge. Definitely not putting it in an area where there's food, because that stuff could get out and into your food, not just out of the solder. So yeah, you know, things to be aware of. Oh, it's heating up. I wonder how I know when it's like maximum temperature. I'm going to move the camera over. We're gonna look at the skillet. Cool. So, this skillet, I was trying to figure out if it was gonna get hot enough to do what I need it to do. And, in the process of trying to Google that, I actually found out that it was listed for $10 cheaper on the company's website. I got it from Target, and so that was kind of cool. Instead of $30, I paid $20 just because I wasn't sure what its deal was going to be. Now, okay, obviously I forgot about the fact that it's going to be hot, so I need to place it carefully. In this case, I managed to not knock any of the components out of place. And let's see, how close can we get that? I'm also trying not to melt the camera, which is the optimal condition. And now let's try and focus in. Hopefully we can get a pretty nice close-up view of this. It's not going yet. What you're eventually going to see... Oh! You know what? I still need to add a little bit more solder onto one of these resistors. My guess is that it's going to start tombstoning. I've still got some left in the... solder paste container. So I'm going to try and just apply that by hand, which is not a great idea. Don't do this at home. Like, I really shouldn't be doing this over the hot skillet. I shouldn't be doing this with my tweezers, etc. But I'm going to do it anyway. Oh, it was that one. The rest of these look pretty good. Okay. Moments of truth. There are a lot of moments of truth in this process. I'm just using a thingy to... Pardon me. I'm just using something to clean off my tweezers at this point. It's not going yet. Oh, yeah, it is! Oh my! That's so quick! It's going silvery on one of the sides, as you can see, hopefully. Let's play with this focus some more. You can see that the solder paste is melting and getting all silvery, and kind of pulling our components into place. Oh, that's so cool. And that should be about good. I'm gonna try adding a little bit more solder paste to a couple of these places because I'm an idiot. Yeah, the problem is when you don't know when to leave well enough alone. So I'm gonna actually stop that. Turn off my skillet. That's so cool! And we're gonna get a close-up look at this thing. Of course, it's very hot still right now. My tweezers are sharp. Teflon coating doesn't like that, but... okay. I gotta leave it alone for a minute. It's really hard to do that. Cool though, look at this. I sort of rotate it around. You can see where the IC is all done, the transistor. So let's have a look at some more of this binary, huh? Over here we've got a very mysterious inscription. It says 1000 10010, which is, pardon me. So what binary is, if I look at it this way, I've got 0 and then 1's place, 2's place, 4's place, 8 place, 16 place. So for you it's going to be like that. So 1, 2, 4, 8, 16. So 1, 0 means 2. It's like this. 1, 0, 0 means 4. 1, 0, 0, 0 means 8. And then it has this whole sequence, which I'm not sure if they are meant to be taken separately or in 3 different rows or all as one piece. I don't know. Let's write it down. I'm gonna pull up text edit on my computer and see if we can figure this out. So it's 001111 01000. Is that correct? I think so. And then 0110 0100. And that is actually pretty familiar for a reason I'll tell you in a second. 1010. Okay, so the second row is 8 binary digits. So 8 ones and zeros. And it starts with 0110. And that's a very common start to an ASCII binary character encoding. So like a letter or a number. In this case, it is 4, which would be D. Yeah. So 0110 and 0100 are the lowercase and uppercase versions of it. I never remember which is which. 1010 is 10, so I'm not sure. It's definitely some kind of a mystery code thing, which really makes me happy. The first row we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. Or digits. Oh. So we can also take it as 2 groups of 12, but we can also take it as 3 groups of 8, because it's 24, you know? 24 numbers total. So let's see what happens if we try to make this into 3 letters. You don't get very much that makes sense because it the top one starts with 0011. The second one row, when you divide it into 3 rows of equal lengths of 8, then you get, the top row starts with 0011, the second row starts with 1000, and the third row starts with 0100. There we go. Which doesn't really, like, none of those really look like they map onto letters, unless the third row was 10. What letter would that be? J? No, I don't think that's right. There's probably a hint somewhere, but I don't know where it is. Let's see if this is cool enough yet. I'm gonna go for it. I also may not have written this down perfectly. Okay. We're gonna come back here. Great. And this guy, ooh, still a little toasty, but not too bad. Cool. Let's have a look. Much better focus. I'm gonna actually give us really nice tight focus here. Alright, so here we've got the transistor looks pretty nice. This resistor looks nice. Most of these other connections look nice, except for this guy has a missing LED, of course. This one looks attached, but not with a lot of solder. All of these are pretty decent. This guy, a little bit thin. This guy, also thin. That might actually just need a glob from the soldering iron. This guy, pretty good. Pretty good. Okay, cool. And the other side? What we didn't get in this case was tombstoning. I kind of wanted to demonstrate that actually. It's what you get when one side of the component lifts up, and then, yeah, so it kind of flips up like a tombstone, right? And that can happen when you have an uneven amount of solder, or like there's hot spots on your skillet, for example, that can happen. Or just any number of other variables. These all look pretty nice. All the LEDs look nice anyway, except for the missing one. In terms of the resistors, they're mostly nice, except for this guy on the end. But even that one looks like it's got a little bit of silver connecting it. So with a little bit more practice with the syringe, I think this could be a pretty good method for me. However, I have a secret. It's not much of a secret. But there's this thing called the SMD Challenge coin. And I have one given to me by Drew Festini from Oshpark / Beagleboard. And he's also been giving these out apparently to a number of other humans. My camp chair is making noises, sorry. And so there's this potential challenge coming up where we might end up racing each other on assembling the SMD Challenge coin. And so what I aim to do over the next few days is sort of figure out what my fastest method is. And the nice thing about the challenge coin is that it has only one side, pretty much. The other side is just a coin cell connection, which is just very large and easy to solder. However, there's a bunch of tiny components on the other side. So I want to see if it will be faster and nicer to use flux and solder, or if it will be better to try with this syringe and dotting method, or what. Yeah, I'm really not sure. This worked okay. I would definitely have to make sure that my skillet is warmed up ahead of time, but that's actually not that much of a penalty. So stay tuned for that, I guess. Other people involved are like Sean Himmel, and I think maybe Chris Gamble is going to be involved. I have no idea who all is in the list now, but it should be fun. So stay tuned. Yeah, so I'm going to sign off for now. I hope you really enjoyed seeing this. I definitely got a kick out of using my own surface mount solder rig for the first time. And it went pretty well considering. I mean, I dropped an LED, but all the rest of the connections seem pretty solid. And I feel like I have a good, I got some good practice in, and I'm excited to see this thing working. So we'll be back later on with part 2 of this. And you'll get to see the other side of the BINCO get soldered and ideally see the whole thing come to life. So stick around. That'll probably come, either later today or maybe Monday. And you'll get to see the whole thing working. Thanks again to Boldport for setting up the Boldport Club. And yeah, thank you for watching. Have an awesome Friday.